Hi folks, welcome to another video lesson. Today we're going to be talking about the properties of logarithms, and this should go with section 8.5 in your Algebra 2 textbook. So today what are we going to do? Well, we're going to use properties of logarithms to help us to simplify expressions. We're going to get some understanding of what these properties of logarithms are. And depending on the length of this video, I may actually do the second objective here as well, which is the use of properties in a real life problem. So we may or may not do that at this point. You may have to wait till class to do that one there. Okay, so what I want you to do here is to make this box that you see here and put all the words in that you see, like the product property, the quotient property, and the power property. We're actually going to fill this in later, but if you have this at the top of your notes, then when you go back to it, you can easily reference it. But I don't want to give you I don't want to give you everything up front. I'm going to actually look at some examples, and we'll see how they work. We'll see where they come from. So I actually want to do a little back work here and talk about what can we do with an expression like this, 2 to the third times 2 to the 2. So this is going to show you why the product property works, even though I haven't showed it to you yet, but it's going to show you why it works. Okay, so the first question is, how can you write this product using a single base? Well, we should know that we can put this together and call this 2 to the 5th, right? We write the base once, and then the important part is what operation are we doing with those exponents? Well, we're adding them, right? This is really 2 to the 3 plus 2. So if you notice what's going on here, when I'm multiplying with the same base, multiplication turns into addition with the exponents. So that's you're going to see that in the property when we get to this later. But this is why this type of thing works. Okay, similar example. This is going to reflect the quotient property. What if we start with 2 to the 5th divided by 2 to the 3rd? Well, we should know that the property says to do, or the exponent property says to do write the same base once, and then it's your numerator exponent minus your denominator exponent. So division with the same base turns into subtraction of the exponents. So this ends up being 2 to the 2, or 4. Okay, so that's a little background to where these properties are coming from. I'm going to skip ahead 2 slides here, and I'm actually just going to go ahead and use the properties. Again, I haven't told you what these properties are yet. I'm just going to go ahead and use them, and hopefully you pick up on the idea of what's happening here. And then we'll go back to, and I'll explicitly say what the properties are. Okay, so I'm looking at the first one here. And so first of all, I'm actually looking at the directions that tell me to expand on each of the following. So that's the verb that's going to get used, is the idea of expand, as opposed to, if you look up here on the right, condensing. So in this first couple examples, I'm going to stretch these out, so I'm going to get multiple logarithms. And then in the condensing, I'm going to start with a couple logarithms. I'm going to condense them down into just one logarithm. Okay, so what can I do here? I'm looking at what can I do with the log base 7 of 21, or log of 21 base 7? Well, it might not be obvious, but I know what I can do with 21, and that's really 3 times 7, isn't it? So I'm breaking that up into its product. Really, it's prime factorization, if you will. Not its product, but it's prime factorization. And, well, what can I do with this? Well, here's what I can do. I can write this as the log of 3 base 7 plus the log of 7 base 7. So I'm turning multiplication into into addition. Just like I did back here. I'm going to go back a couple slides. And again, we multiplied, right? We multiplied with the same base, and that turned into addition with the exponents. Remember what a logarithm is. A logarithm is just an exponent. So when I go back ahead here, and I'm turning multiplication of the argument, 3 times 7, into addition of the 2 logarithms. So that's the property that I'm using there. Okay, this one has a little more I can tidy up. If you notice here, I have the logarithm of 7 base 7. We saw that the other day, right, when these the arguments right here in the base are the same. What number is that? Well, that's just 1, right? Because 7 to the first power gives me 7. So I can actually simplify this a little bit more, and I can say the log of 3 base 7 plus 1 is the expansion of what I originally started with. So that's got that little extra step in there. But again, we should keep seeing those so we get used to them. Okay, so now let's look at the log of division this time. So I have division going on in my argument. So how does that change what I can do? Well, I can write this as the log of the numerator, 11 base 7, minus the log of 3 base 7. So again, the idea here is that the log of a division operation, right, turns into subtraction. And notice how in both of these, I start with the logarithm written just once to the logarithm written multiple times, right? I have multiple times written in the logarithm because I'm expanding this. I'm writing this as multiple logarithms. The final answer, you notice how in down here, I end up with just one logarithm, right? Well, that was a special case because of the log of 7 base 7 was just 1. But I certainly can end up with, and I often will end up with log written more than once. Okay, let's look at a couple properties combined. I have two properties actually combined in this last one. So let's take a look at what's going on. Okay, so I have this is the natural log, right? This is log base e. Not that you need to write it like that. We write ln, but that really is just log base e. Okay, so I have a product here, right? I have 16 times e to the 5th. So I'm gonna split this up. I'm gonna call this the log of 16, and again, multiplication turns into addition of the logarithms. So this becomes log of 16 plus the log of e to the 5th. Okay, so what can I do with this? Well, the 16, remember, 16 is a special number. I need to think of that not really as 16, but either as 4 squared or better yet, 2 to the 4th. So I'm going to write this as the log of 2 to the 4th. And I'm just going to rewrite this natural log of e to the 5th. Okay, so here's the other property that we have here. I can take this exponent and I can pull it out front like a coefficient. We're going to see that property in a second, but I'm allowed to do that. So that's another part of the expansion I want to do here is pull that 4 out front and write this as 4 times the natural log of 2 plus, well, I'm going to do the same thing with the natural log of e to the 5th. I'm going to take the exponent and I'm going to pull it out front like it's a coefficient. So this becomes 5 times the natural log of e. Okay, of course we have a little more wrap up here. These wouldn't be nice problems here if I didn't add a little extra to these. So what can I do here? Well, 4 times the natural log of 2, I'm going to leave that as is. But remember, natural log is base e, so this here is really the log base e of e. Well, when these are the same, this is the log of e base e, that's really 1. So this is really 5 times 1. So I can put on the end of this just the plus 1 in place of the 5 natural log of e. So there's my solution. There's my expansion of what I started with, and I end up with 4 times the natural log of 2 plus 1. So we saw all 3 of the main properties right there. If you didn't quite catch what was going on there, go watch that again, and that might give you a little more insight there. We're actually going to do some condensing problems now. So I'm going to condense these 2 long log expressions. I'm going to use the same properties, but this time I'm going to reuse them in reverse. I'm going to put stuff together and end up with a single logarithm with everything inside the argument. I'm going to have nothing, I'm going to have no coefficients like the 2 or the half. That's all going to get inside their logarithms when I condense these. So again, here's the verb I'm using. I'm condensing. So I'm going to write this as a single logarithm, and everything's going to go inside. Okay, so here's what I'm going to do. The first thing I noticed that I have this 2 that's outside the log. So I'm going to put this back inside. So I'm going to rewrite my first line as log of 6 plus, I put the 2 inside, that becomes 2 to the 2, right? So this is going to be log of 2 to the 2, or if you want, you can just write 4. That's certainly easy enough. I'm going to write it so that people see exactly what I've done there. And I'm going to write minus the log of 3. So I'm going to rewrite this just so that we see it. This is the log of 6 plus the log of 4 minus the log of 3. Okay, so that's the first property. That's called the power property for logarithms. So I put that exponent, put that power back inside. Okay, I'm going to do this in one more step. I'm going to do this all in one shot. So watch what I do here. I'm going to end up with a single logarithm. So I'm writing log, and I'm going to end up with a fraction. And I know that because I have subtraction going on here. So that's telling me I'm going to get a fraction. I'm going to get stuff in the denominator. Okay, so any argument like the 6, pardon me, the log of 6 is positive, right? This is really a positive out here. So this factor is going to go in the numerator. So I'm going to put a 6 in the numerator. Well, do we have any other logarithms that are positive? Yeah, the log of 4 is positive, right? This is a positive log of 4. Oops. So I'm going to put a factor, not adding, but a factor of 4 in the numerator. I'm going to clean that up, but right now I'm just going to put it in there. Okay. Any logarithm that's positive, again, that factor goes in the numerator. Okay. Any logarithm that's negative, like this last one here, that factor of 3 goes in the denominator. So I'm going to put a 3 down here. And that's basically, and I'm going to simplify because I have 6 over 3, but that's basically the end of the story here. So I used my, hold on a second, let me just cancel this a little bit. 3 goes into 6 twice, and I get 2 times 4 is going to be 8. So that does simplify to just the log of 8, but that's because I've got the fraction in there. So just to summarize what we did here, again, go back up to the top here where we started. The coefficient went back inside as an exponent. So that term became log of 2 squared, or log of 2 to the 4th. And then again, once I put all those coefficients back inside, I wrote this as a single logarithm right here. And any factor, any log that had a positive coefficient out front, that factor goes in the numerator, like the 6 and the 4. And any log that has a negative out in front, or subtraction, that factor goes in the denominator, like the 3 went in there. And then I had a little simplifying, right? The 6 over 3, that simplified. I got the log of 8. And you can certainly put all this in your calculator. Being that I just used numbers here, I didn't use any variables. You can put this whole thing in your calculator and get a nice little decimal from that, and then put in the log of 8. And then you should get the same thing, because they're equal. Okay, let's look at one more example here where we're going to condense again. No new operations, no new formulas here, or no new properties, but just a little different problem here. So first of all, I'm going to clear all this other stuff out and make some room so it's nice and clean. Okay, so same ideas here. Any and all of these coefficients are going to go back inside as exponents. So this first term is going to be the natural log of 5 to the negative 2. I'm going to leave it like that for now because I don't want to deal with the exponents yet. I'm going to just simplify the process here. And that 1/2 is going to go in. I'm going to get 100, the natural log of 100 to the half. Okay, so now I need to actually deal with, I'm going to simplify these exponents here. So this first expression, this first term, I'm going to have 5 to the negative 2. Well, 5 squared is 25, and the negative means reciprocal. So this ends up being the natural log of 1 over 25. Plus, well, the 100 to the 1/2, that means the square root of 100. That's just the natural log of 10. So I have 100 to the half, that ends up being the natural log of 10. That simplifies kind of nicely. Okay, so what am I going to do here? Well, this is a positive log now, right? So I'm going to put this factor of 1/25. I'm going to write this as 1 natural log. 1/25 in the numerator. Well, you can write it like that all in the numerator, but I really want to write it like this, so I don't end up with a fraction inside of a fraction, right? So that 1/25 can go in like that as 1 over 25. And then this factor of 10, again, this is a positive natural log of 10, so that times 10 is going to go in the numerator. So this is going to simplify a little bit as to the natural log of, well, 10 over 25. 5 can go into both of those. And I get the natural log of 2 over 5. So a quick word about these expanding and condensing problems here. If this stuff was not obvious or accessible to you, you are not the first person that this has happened to. So relax. The quiz on this tomorrow is going to be very light, and you'll see when we get there. We'll just have some basic problems here. But this is definitely something we're going to get some good practice on. So don't freak out if you're looking at this stuff and you're like, I have no idea what's going on. So we'll certainly take a much deeper look at this in the days to come. Okay, so let's go back to our properties here. And now let's go, you're going to have to flip back probably page yourself. And we're going to fill in our properties of logarithms. We're going to talk about the product property, the quotient property, and the power property. Okay, so the product property says this. Let's start with the log of a product, u times v. Okay, I'm gonna write this as any base b. B could be anything. It could be e, it could be 10, it could be 2.5, whatever positive value we want b to be. Okay, so what do we do? If we have the log of a product, we turn this into the addition of two logs. So just like with exponents, we added the exponents, right? So I can call this the log of u, base b, plus the log of v, base b. So we expanded this out, right? We can expand the log of a product into the sum of two logs. And likewise, we can work right to left, right? We can work this way, right? If we have the log of the sum, we can turn it into a product. Okay, that's the product property. The quotient property says, okay, let's start out with a quotient. Log of u divided by v. Well, what did we do when we had division inside the logarithm? That wasn't addition again, that turned into subtraction. So this became the log of u, base b, minus the log of v, base b. Okay, the last one, and this one you just kind of have to take my word for it at this point here. But we have the log of a power. And your book uses the letters of u and n. So I'm going to use log of u to the n base b. Well, what did we do with that exponent? Well, we took the exponent n and we put it out front like a coefficient. So I can write this as n times the log of u base b. And likewise, this also can work right to left. I can take this, the coefficient n, and I can put it inside, right? I can put it up in here and write this as u to the n. And that would be working from right to left. That would be like when we were condensing, we did that properly. Okay, I have one more task for us to do today. This is where you're going to need your calculator, so hit pause on your screen if you need to, and go grab your calculator. We're going to evaluate the log of 21 base 7. Okay, so I'm going to bring up my calculator here. And let's see, quit out of this. Okay, let's hide that. I'm going to move this over here a little bit. Okay, so now the problem that we have at this point here is that I'm asking to evaluate the log of 21 base of 7. If we had base 10, I could just use the log button there, right? Or if I had base e, I can just use the natural logs button. But that's not the base that we have. It's 7, and our calculator isn't, we don't have a hard button for base 7, but we do have a button for it. Okay, if you have a TI-84, hold on one second. Okay, sorry about that. If you have a TI-84, you're in a bit of luck. We actually can just put it in the way we see it, but you have to hit a couple buttons first. We're going to hit the alpha button, right? The alpha button, which is, I might as well just circle the whole thing, is right there. So you can hit alpha first, and then you can hit the button up top that says window. So hit alpha and then window, and then look at what it says for number 5. Okay, not what I expected to happen. So if I hit alpha and then window, number 5, see where it says log base? So when I choose that, look what I have on the screen. It looks exactly how I want it to look. I can put a 7 in where the base goes. I push to the right. I hit 21. I hit enter, and it tells me the exponent, where 7 to the 1.56 is going to be 21. Okay, excellent. I'm done with this problem here. 0.56. I'll put another decimal on there. Okay, so let's say that you don't have this ability. Even some of the TI-84s don't have this if you don't have the new operating system. What can you do here? Well, here's a property that we can use that's going to help us out. Again, I'm going to close this. It's going to save it. Again, another little weird thing it does. Okay, so again, we said it was about 1.56 something, right? Okay, so here's what we can do. I can write this as a fraction. And it's going to look a lot like the way that we see it here. It's going to be 2 logarithms. The log on top is going to be whatever the argument is. Notice how the 21 is a little bit above the 7. So the log of 21 goes up top, and this is divided by the log of 7. So this is actually a new property. I'm going to name it in a moment here, but that's actually how we can type it in. Notice how I can put any base I want in there. I chose base 10 because I have a button for log base 10, right? That's right on our calculators. So I chose this to be base 10 in here and in the denominator, right? These are both base 10. So when I go to my calculator again, I can do the log, I'm hitting the common log button of 21, close the parentheses, divided by, again, common log of 7, close the parentheses. And I hit enter, and I'm getting the exact same thing. So I'm getting the 1.565, I guess was the 3 decimal answer on this. So that's a neat little formula here. It's called the change of base, which I'm going to write on the very next page here. Okay, so here's the change of base formula. So we're going to let U, B, and C be positive numbers. B is not 1, C isn't 1. Okay, so we don't want our base to be 1 here. So if we have the log of U base C, again, this is some number that I can't put in my calculator usually, right? It's not 10 or it's not E. We have this change of base formula that says I could change this to log of U over the log of C. I can do that with common log. I can actually do that with any log, so I really should put base B down here. But the important part is you choose the new base. You get to choose what you want. And again, on our calculators, we have base 10 and we have base E. So it makes a lot of sense to choose base 10 or base E, whichever button you want to push, the common log or the natural log button. Okay, so just for kicks here, why don't you folks try another one here. Find the log of, let's do 17 base 8. So try that one, I'll give you guys the answer here. Okay, so I typed this in my calculator. I actually used the change of base, even though my calculator I could have done this just by plugging in. Again, I get about 1.362. So hopefully you're getting the same thing. Hopefully you're able to use your calculator to evaluate some of these logarithms. It makes it a lot easier. Okay, so I'm going to skip over, hold on one second. I'm going to skip over this last application problem. We're going to look at this in class tomorrow. So you might want to write this down, get this in your notes, and we'll answer these questions when we have a little more time, but I'm certainly upwards of 23, 24 minutes here. So we did one of these things, right? We looked at the properties of logarithms. Hopefully they helped us to simplify expressions. And again, we're going to look at, in class tomorrow, some real life problems. We're going to look at the that decimal, that sound problem that was on the last page. So if you need to go back and get them in your notes, and then we'll fill it in tomorrow in class. All right, take care. Have a great day.